All right, here we go. Let's keep this going. I thought we had a tremendous review yesterday. Had people showing up after school. I thought that went pretty well. So let's keep this show going here. Last night, Will, go ahead. Number 9. Okay, writing equation of a line perpendicular. All right, here we go, everybody. Number 9. Midterm review number 2, number 9. Okay, first thing, write the equation of a line perpendicular. What are we thinking about perpendicular lines? Slopes are negative reciprocals. So we got to remember the slopes, negative reciprocals. And we're asked to write the equation of a line. So we're starting to think, y equals mx plus b. All right, so let's start with the line they gave me. Negative 3y minus x equals 6. Let's help me get that into y equals form so I can find the slope. Move over what first? Move the x over. So I have negative 3y equals positive x plus 6. And then divide both sides by negative 3. So the equation of this line is going to be y equals, now what's in front of the x, even though nothing, it's never there, a 1. So this is negative 1/3 x. Everyone good on that part? Let me stop there. That is negative 1/3 x. Now you can just keep 6 over negative 3, but 6 over negative 3 is negative 2, so we'll write it. What's the slope of this line? Negative 1/3. So if I go negative reciprocal, what's going to be the slope of my perpendicular line? Positive 3. I got the tough part done. Now I just need to find what's the y-intercept, and we did a problem similar to this yesterday. How do I find the y-intercept? I plug in the point that that line goes through. What's the y-coordinate? Y-coordinate. Negative 1 equals the slope we just found was 3. What's the x-coordinate? 6 plus b. And now I'm on my way to solve. Negative 1 equals 18 plus b. So the y-intercept is negative 19. I put the 2 together to come up with y equals 3x slope minus my y-intercept of negative 19. Yep, Cam?
Number 11.
Okay, let's get right to the proof, everybody. I'm not going to write too much down just because you do have the answer key available, so I'm not going to do a full-out proof and just recopy what I have already for you guys on Aspen. Oh, no, I did not. There we go. Okay, I have to prove, let me highlight them. These two lines parallel to each other. So I need to start thinking all the different types of angles that are formed by parallel lines. Don't give me specific letters here, just in general. If I have two lines that are parallel, name the different types of angles that could be formed. I could have alternate interior. Next, this is all review. Corresponding. Alternate exterior. There's another pair I want you to know as well, the ones right inside here. Okay, consecutive interior, that's fine. We called them same side interior. All right, same side interior. Do you see any of those special types of angles formed by these parallel lines? What do you see, Will? So do I. Name the alternate interior angles up here. I'm just going to put a 1 and a 2 in the angles Will just gave me. 1 and 2. Those are alternate interior. So if you can get those angles congruent, what would I know about the lines then? They're parallel. Well, that's your job in this proof, is to get angle 1 and angle 2 congruent. Yes, Amy? Okay, go ahead.
Like, I had 10 steps, and I made triangle DEA
Yep.
and triangle BFC congruent.
Okay, I'm listening.
And then I used CPCTC
Yep.
to say DA and CB are congruent.
Okay.
And then reflexive additions, so that triangle DEC and triangle BFA were congruent, and then I used like implies a parallelogram, and then parallelogram implies opposite sides are parallel.
Oh, so you proved it a parallelogram. So that's what you did.
Yeah, but then I said they're opposite sides are
No,
parallel.
I know, but you proved it a parallel. You proved the entire figure a parallelogram. Okay, that's fine. Sean, is that where you're gonna?
Yeah, I did a little bit.
Okay, that's fine. All right, perfect. That's fine. Okay, just going back here though. Hey, going back here. If you didn't prove, all right. If you didn't prove it's a parallelogram, you needed to get these two triangles congruent to each other. How do I get those two triangles congruent? Everyone ready? DE and BF are altitudes. Right angles are congruent. AE is congruent to CF. Now, are those full sides in the triangles I'm trying to prove congruent? Take a look, a little help here. Are these two full sides in the triangles I'm trying to prove congruent? No, but how do I make them full sides? Add what to each of them? Reflexive EF. All right, so I have a pair of angles, a pair of sides now, and where do the other parts come from? Well, I already was told DE is congruent to BF, so you have side angle, side after you do your addition substitution. And then you could say CPCTC, these angles are congruent, and then the lines are parallel because congruent alternate interior angles imply parallel lines. Okay. We good there? Anybody else want to add in any other information, other methods to do it? Okay. More questions before we move on to what we had to do today. Anything else from the homework? I do not know if we're going to get through what I want to get through today, which is the rest of midterm review number 2, but you guys have the answer key there now. Okay, so if you want to go back on your own and finish midterm review number 2, whatever we don't get to today, you have the answer key up on Aspen. No big deal. Before I do that, I did not mention any of this yesterday, and I want to do that right now. And that is what to bring to the midterm and what to expect format-wise on the midterm. So if you go to your packet for me, you'll see a supply checklist that I just want to cover real briefly with you right now. And you can ask any questions you need to about it. Make sure you bring some blue or black pens. Everyone ready for this little note here? The entire test is going to be done in pen, except for any construction or graph you do. Okay, entire test. Anything you think will be in pen, except for a construction or a graph. Okay, you will be given for your part 1 multiple choice, they're already right here, a bubble sheet. That's in pen too. Okay, you'll be given a bubble sheet to fill in for your part 1s. Okay, that's in pen. Pencils with erasers. You need the pencils for the constructions and the graphs. If you guys choose to do the entire thing in pencil and then go over to pen before you hand me it, that's fine too. All right, I'm okay with that if you're worried you're going to make a mistake. Please bring your calculator. Make sure it's charged or has fresh batteries. I am not going to bring any extra calculators to the exam with me, so please make sure it's charged or has good batteries in it. We'll go over how to clear the memory here in a minute. Your compass, if you need a Titan, that's fine. I'll bring the tightener with me. A straight edge, A game, and no excuses. Okay. Please, I would advise Sunday night, put everything in a Ziploc bag. Make sure you have it. You're good to go. All right. You don't have to worry about running around the house at noon on Monday. I'm an hour away and I can't find this. Yes, Emily. Yes, absolutely. You can bring the highlighters to highlight. You can bring in some water if you need to, extra batteries, whatever. Okay, you can bring in any extras you need, highlighters included. Any other questions on your supply list? Do you have your calculator on you right now? I will, during the test, before the test, I'll be doing the announcement part of it. And one of the announcements is going to be, please right now, clear your graphing calculators. And I don't have the time because it's going to be you guys, and I got 2 other geometry classes taken in Gym A. I don't have the time to stop individually and say, oh, remember, this is how you clear it. You guys are responsible for that on your own, please. Here we go. Ready? And we're going to practice this today, tomorrow, and Friday. Second plus. So once you get the go-ahead to clear your memory, second plus. Number 7, reset. Number 7, reset. Now here's the key you got to remember. Go over to all memory. Hit all memory, and then it'll have an option to reset. Reset number 2. And then a screen will pop up. Some of yours will say MEM cleared. Some of you will say RAM cleared. That's the screen I want to see as I fly up and down the rows in Gym A. Okay, that screen right now, I want to see MEM cleared or RAM cleared as I fly up and down the rows. I would greatly appreciate it if I did not have to stop and watch you do it. All right, I just want to fly up and down the rows. Just let me see the screen because I have about, let's see, 50, and you guys are about 70 of my students are going to be in that Gym A. Okay. Everyone all good? Second plus, number 7. Yep. Okay, we'll talk later on how to do that. All right, do you have a button on the back that says reset? I think you can do it that way. Okay. Others? Anything else? Okay, so we're good to go resetting it. We'll do that first thing tomorrow in class. You guys have any last minute questions before we get reviewing about the test format or the test? Yeah, I should probably, sorry. Test format. If you haven't seen it already, it's 3 parts, 80 points total. Over half of those come from your multiple choice. When I say 6 open-ended questions, that show your work, could be a construction. All right, that's what I mean by open-ended, and then you got 3 proofs at the end. All right. 2 hours to take it. I can't give you any more time. Once 3 o'clock hits, everybody's done. So make sure I don't think you'll need, because what is it? 28, 31 questions in 2 hours. I think that's enough time. Justin.
Does the coordinate proofs count in the 3 proofs or open-ended?
Okay, what did you call them again?
Well, I was just making sure.
What did you call them again? Okay, there you go.
Well, I was making sure.
All right, that's fine. And I am not going, and people have been asking me, and I refuse to tell you what proofs are going to be. Okay, but let's put it this way. There are 4 huge types of proofs we've done so far this semester. What are they? What type? 4 huge types of proofs. Justin? Coordinate proof. What other types have we done that are a huge chunk of this year? Coordinate proof. Quadrilateral proof. Proving triangles congruent. And the different kind. Indirect proofs. Proof by contradiction. Those are the 4 big ones we've gone over. So, hey, all right. They are in your packet. Okay, they're in your packet. Okay, let's get reviewing. You guys got individual questions. You know where I am. You know the extra review sessions. All right, here we go. We're on midterm review number 2. Let's get through as many of these multiple choices as we can. All right. Where am I here, by the way? 12:30. Okay, perfect. Okay, we got some parallel lines. By which method can WZY, I just want to see which ones we're working with, be congruent to YXW? YXW. So, right on top of each other, huh? These ones right on top. Everyone all right? By the way, I know it looks like it, but does it say anything about being a rectangle? No. No assumptions either. All right, so don't assume, that looks like a right angle. I'll put one there. Nope. Okay, here we go. I got parallel lines. And which method would show they are congruent to each other? Well, what's up, Will? Well, give me parts that you know are congruent.
So the opposite angles are congruent.
Why are the opposite angles congruent? Oh, yes, not a parallelogram. Remember, not a parallelogram. We'll get there, though. Well, they share something, don't they? They share a side. So maybe I can use that side there that they share. Remember, I have parallel lines. We just talked about special types of angles formed by parallel lines. Anybody see those special type here? There's alternate interior. Name them. Name a pair of alternate interior angles. ZWY. Yep, right here with WY. Nice one. Nice job, young one. I got a pair of alternate interiors right there. Okay, so I got a pair of sides. I got a pair of angles. You're darn right there's another pair of alternate interior. Where are they? ZYW, everybody, right here. And XWY, another pair of alternate interior because these lines are parallel. Yep. Okay. Now the only thing is this, ready? Let's cover up one triangle here. Is that reflexive side in between those two angles? Is that, yeah, it is. So we're going with what? Angle? Side angle. Any questions? Going? All right, let's, yep, Emily? Did I? All right, that might, let's see, how did I get side angle side then? Well, it should be angle side angle. Okay. Side, yeah, I don't know where I'd get side angle side unless I got these, but that's not happening. Yep. Okay. Are there questions on?
The reflective side is in between the two angles.
Right? Here are the two angles. Here's the side in between. We all good? Okay, number 2, find the length in simplest radical form of the segment whose endpoints are the following. What am I going to need here? Distance. Am I going to give that to you? No. Here we go. I will give you a scrap sheet of graph paper if you want to do Pythag, though. Okay, so that might be an option. Distance formula, x2 minus x1 squared plus y2 minus y1 squared. All right, let's do this. What are my x coordinates? 3 and -1, so it'll be 3 plus 1 squared. And then what about your y coordinates? 4 plus 2 squared. The order of the x's and the y's don't matter in the distance formula, just as long as they go together. All right, so I'm looking at, let's see, 4 squared, which is 16, and 6 squared, which is 36. Woo! Square root of 52. Direction said what, though?
Simplest radical.
All right, how much practice have we gotten with this year?
A lot.
Probably more than you had last year. Anybody know the biggest perfect square that goes into 52? 4 and
13.
square root of 4, 2, and then square root of 13. Yes.
Kind of like a weird question, but like on the part of our midterm when we have like the 6th thing, is there gonna be like a line like next number 2? You know how it's like not multiple choice? Should we write the answer on the line?
Just circle. Let's circle or write it on the line. That's fine. I'll search for it somewhere. Woo! 3 is hardcore. Buckle up. Ready? AD is congruent to BD is congruent to CD. AXC, AXC? The full angle is 4x plus 6. AXD is x plus 7. Find DXC, the angle next to it. Woohoo! No joke, this one. Probably have no idea what's going on here. And that's fine, because it's been since Unit 5 since we've done it. Everyone ready? Point D. Point D is equal distant away from all three sides. That's why I told you they were all congruent. We have a point that is equidistant from the sides of a triangle called the point D is the incenter. That's the point that's equidistant from the sides. All right, let's keep building. Incenter is the intersection of all three. And I guess you could probably tell from what I gave you here, but all three angle bisectors. Yep. So BX, everybody, BX is an angle bisector. BX is an angle bisector. Okay, now I'm not going to give anything else away. Can you come up with the equation now? If BX is an angle bisector. You ready, Will?
Yep.
Okay, let's see what you got.
X plus 7 times 2.
Oh, nice. Again, why do you do x plus 7 times 2? If BX is an angle bisector, those two angles right here are congruent. 2x plus 7, 2 times x plus 7 will equal to the whole angle, which is?
4x plus 6.
Good man. There we go. Any questions on in-center? Aren't there other points too other than in-center that you may need to review? Centroid, circumcenter, orthocenter. Yep. 2x plus 14 equals 4x plus 6. 2x equals, we got there, 8. X equals 4. And yeah, I tried to trap you in, right? Circle 1, everybody. Circle 1. Circle 1. Was I looking for x? Nope, I was looking for angle DXC. How do I find DXC? Plug it in where, though? As in AXD and DXC congruent? So I can just plug it into x plus 7. So 4 plus 7 gives me that 11. Questions? How you guys feeling here? Should we keep going over these as a class, or should I just let you take over? Because I don't know what's more beneficial, seeing us do the problem together or trying it out on your own. You guys have the answer key in front of you, but
If you have questions, we can ask you.
so you want to just go on your own, you're telling me?
Yeah, boy.
Okay.